Welcome. We're now going to take a look at an example and introduce what is called factorial notation. So let's start with the example. In how many different ways can you schedule your day running errands if you must go to 6 different stores in one day? Okay, so you wake up to start your day and you're going to start heading out to different stores. So the first store that you go to, you can pick any of the 6 on your agenda for the day. So you've got 6 choices for the first store. And then after you visit that store, when you pick your second store, there would just be 5 left to visit. And after you go there, you'd have 4 choices. And then you go to that store, we'd be down to 3 choices, and then 2 choices. And finally, just your last store, you'd have that 1 choice, the last store left. All right, so the fundamental counting principle says to multiply those numbers of possibilities for each of your decisions on store. And this is where we introduce some shorthand called factorial notation. So writing that first value 6, and a factorial symbol is an exclamation point. So this is a shorthand way of saying 6 times 5 times 4 times 3 times 2 times 1. So similarly, 5 factorial, 5, 4, 3, 2, 1. 3 factorial, 3, 2, 1. And I just made a note up here. 0 factorial is actually defined to be 1. We won't have to worry about that too much for our purposes here, but just a note. So our calculator actually has the ability to enter 6 factorial. So I just thought we would do that first. So I'm going to enter the 6 on the calculator. And then my math button. And I'm going to arrow over to my probability menu. And we're going to be investigating a few things here. So we're not going to worry about random right now, but number 2, NPR, we'll get to. And then number 3, NCR, we'll get to. But right now we want the factorial symbol, so that exclamation point. So I'm going to arrow down to it and hit enter. And then we'll have 6 factorial on the screen. Enter. And that multiplication would end up being 720. So you would actually have 720 different ways you could run your errands for the day if you're going to stop at 6 stores. So it sounds like a lot of options, but there you go. All right, now the factorial symbol comes up in equations and formulas, but as we move forward, we're actually going to take advantage of technology and not necessarily need to use it, which you'll see in a moment. So let's move on past the fundamental counting principle, and we're going to talk about permutations and combinations and what those words mean. So we're going to do this with an example. All right, I'm going to have 3 students, Beth, Ed, and Rich, who just happen to be my siblings, so that's why I picked them. So Beth, Ed, and Rich, and they are competing for 2 scholarships. So first place scholarship will be $1,000 and second place will be $500. No student gets to win both scholarships, and we're going to make a list of all the different possible ways that the scholarships could be awarded. So in other words, from these 3 students, we're going to list all the possible ways we could position just 2 of them to get these scholarships. So I'm basically just going to start a list. So for example, Beth could get the $1,000 scholarship. I'll do B for Beth, and then I could award Ed the 500. So that would be one option. Or let's start with Beth again. Beth could win $1,000 and we'll award Rich the 500. Okay, let's move on to Ed first. So Ed gets 1,000 and we'll give Beth 500, or Ed gets 1,000 and Rich gets the 500. And then finally, let's start with Rich first. So Rich gets 1,000. We'll do Beth 500, or Rich gets 1,000 and Ed gets 500. So if we count there, there's 1, 2, 3, 4, 5, 6 different ways to award the scholarships. So there are 6, and let me talk vocabulary here. So let's focus on Beth getting 1,000 and Ed getting 500 versus Ed getting the 1,000 and Beth getting the 500. So Beth Ed versus Ed Beth are very different things, especially for them, right? So this one, Beth gets $1,000, but this one, Beth only gets 500. So what we say here is that if we change the order, it results in a different outcome. So Beth Ed and Ed Beth are different outcomes. And sometimes you will hear people refer to that as order matters. So order matters means we switch the order and something new occurs. And in that situation, these 6 arrangements are called permutations. So there are 6 permutations, so arrangements in which order matters. So 6 permutations of these 3 students where we took 2 of them at a time. All right, so I'm going to show you how we can get 6 that answer without, again, having to make lists, but we'll do that in just a moment. I want to just first compare this example to the next one. So it says, let's consider these same students, but this time we're going to choose 2 of them to be on a doubles team to represent the school at a tennis tournament. So from these 3 students, we're going to list all possible ways to choose 2 of them to be on the team. All right, so what we want to look at here is the same students. So let's do our tennis teams. So I could put Beth on the team and Ed on the team, so that would be a team. And then I could also put Beth on the team and make Rich her partner, so that's a team. And then let's get to our Ed and Beth and stop there for a minute. So when we're talking about teams, Beth Ed are a team, Ed Beth are a team. Those are the same team, right? So these are just 2 people playing on a team together. So Beth Ed and Ed Beth are not different. So these are not different teams, not different outcomes. So you'll hear this referred to as order doesn't matter, because when you're on a team here, it doesn't matter what order we list. In this case, those 2 people, the outcome is the same team. So when I make my list of possibilities, I can cross out Ed Beth because we already have that team. And then we'll keep going. So Beth and Ed could be a team. Beth and Rich could be a team. And then Ed and Rich could be together on a team. That would be a new team. And then Rich and Beth could be a team. But we already listed them up here, right? Beth and Rich are a team already, so that's nothing new there. And then Rich and Ed, but we already have Ed and Rich as a team, so we already listed that team. So now possible teams, Beth and Ed could be a team, Beth and Rich could be a team, or Ed and Rich could be a team. So we only have 3 ways to form a team. So when we arrange objects, but the order doesn't matter, so switching the order doesn't create something new, we call those combinations of objects. So we have 3 combinations of 3 students taken 2 at a time. All right, so we're going to use our calculators to find these answers, and let's just start notation. So going back up to permutation, so capital P for permutation versus it will be capital C for combination. And then we're going to have 2 subscripts. The subscript on the left will be n. So that's going to be the total number we have to choose from. So in my case here, n would be my 3 students. And then our calculator does a lowercase r for how many of those we will be choosing. And in this case, that would be, we're picking 2 students. So a permutation question. So we want to know how many ways to arrange if we take from 3 people, 2 of them to award scholarships. All right, I'm going to write that down here now for combination. Same process. So for combinations, we still have those 3 students and we'll be picking 2 of them to put on a team. All right, so we want to get this answer 6 and that answer 3 using our graphing calculator. So let's do permutation first. So I'm going to hit the 3 first and then back to my math button and over to probability and pick NPR. So my calculator actually shows subscripts. The older calculators won't. You'll actually see, I'm just going to write it here. So if you have an older calculator on the screen, it will actually say 3 NPR. And it doesn't matter which calculator, we're still going to enter the 2 next. So I'm going to enter the 2 and hit enter. And we will know that there are 6 ways to award the scholarships. All right, let's do it one more time with combination. So we hit the 3 first, math button, probability, and now NCR for combination, and then the 2. And there's that answer 3 we were looking for. So without having to make a list of possibilities, we're able to figure out how many in each case. All right, so at the bottom of the page here, I do have kind of a summary of that and a visual. So for permutations, like awarding those scholarships, you want to think when you read a question if there's an ordering or a positioning, a ranking, and that's our key that we're talking about, positioning where order matters. And combinations are just collections. So there's no grouping. A team is just 2 people playing together. This could be a 3-person team maybe on the visual, but there's no ranking, no positioning, no ordering. It's just a collection. I also included the actual formulas if we were going to do these by hand, and you'll see that factorial symbol show up. So nothing wrong with doing these by hand, but we do have these features on our calculators that we can also take advantage of. So I'm going to go with technology here and find our permutations and combinations that way. All right, and the next step is to practice problems where we look at the counting rules that we've learned. So fundamental counting principle, and then permutations, combinations, and probably the hardest part is trying to figure out which situation we're in, and then we go forward from there.